Okay, we'll get going. Hello, everybody. Welcome to our Southwest Marine Ecosystems Cetaceans webinar. It's great to see so many people here. I'm Lauren Storer, and I'm the project coordinator for the Exeter Marine Research Network, and I'll be hosting the webinar this evening. We've got a whole range of talks coming up over the next few weeks, hosted by ourselves and then the other partner organisations within the Southwest Marine Ecosystems group, on a variety of topics, so please do check them out as well, and I will put the schedule for the upcoming webinars in the chat. All of these webinars are recorded, including this one, so if you do need to drop out, don't worry, because you can watch them back later. Tonight we're going to hear from 7 fantastic speakers, which means we'll finish about 8:15, and there will be a comfort break in the middle. We are quite tight for time, so we'll be doing a question session at the end. So if you have any questions throughout, please do put them in the chat, and our speakers can either address them as we go through the session, or we can talk about them at the end. So on that note, please do keep yourselves muted for the duration of the session until we reach that questions point. At which point, if you would like to ask a question verbally, I can unmute you if you raise your virtual hand. So we'll get started right away. I'll hand over first to Duncan Jones from Marine Discovery Penzance.
There we go. Is that working? Can you see that? Excellent. Hi, so yeah, I'm Duncan Jones from Marine Discovery, and I'm going to be reviewing cetacean observation trends, actually using more than 10 years of effort data and considering whether this can tell us anything about the wider health of these populations. So typically for Southwest Marine ecosystems, we've been really in the past just using observation data. And what I mean by effort-corrected data is really when, with the observation, you have a bit more information about how that observation was collected. So, for example, you have the amount of time someone took searching in order to see that animal, but also the conditions under which they made the observation. So the things like the sea state, if they're on a boat, the speed of the boat, time of the year, and all these things can actually affect the probability of detecting an animal. And in fact, if you look at effort data, and the more you look at it, and the more you look into it, the more you realise how these factors affect your likelihood of observing an animal. And where we're looking at changes in Southwest Marine ecosystems and numbers of animals between years, when we include if you consider the effort data, there are factors within that could actually affect the number of animals you see more than the fact of whether there's more or less animals. So, for example, if lots of your survey days were in high sea states, or if you spend less time looking, you're going to see less animals and vice versa. So that's why the effort data is really important. We're looking at 3 different data sets. Ellie Kepi from Orca is actually going to talk about the Orca organisation cetacean data. The reason I've put this map in is really just to show the area it covers, because the Orca data really does cover the whole of the Southwest, and we get offshore and inshore data. This map, it just shows the data gridded at 5 kilometers, and the redder the cell, the more effort there is in that cell. But she'll talk more about that. My other data set is the Sequest Southwest data. So this is a land survey. So where the Orca data was the effort or the amount of time searching was in kilometers, this is actually in hours searching from cliff-top locations. And it's data collected on Sequest Sundays, public sea watches, and also by independent surveys by as well. And the little bubbles, they represent really the distance of the survey effort. So they're about 5 kilometers from the survey point. I know if you're a Sequest observer, you might know that some observations are 10 kilometers or more when people are using scopes, but I've just mapped it like this because it's really in all sea states consistently the distance people are recording cetaceans from the sites. And again, the redder the bubble, the more survey effort there is there. And then this shows the hours of Sequest effort. So 2011 was a great year for people out surveying, but typically the trend is up. So we've got more hours of searching or surveying effort. The other data set is my data, my marine discovery data. So really, the marine discovery data is quite spatially constrained. We're really only looking in the western part of Mounts Bay. For this analysis, really, it's whether there's animals in our area or not. So I haven't actually put any distribution maps at all with my marine discovery data because it's not relevant to what we're talking about here. This does show our survey effort, and what we typically use our data for is really fine scale analysis. So we're looking at like different oceanographic processes at a very fine scale and seeing how they're influencing distribution of animals within Mounts Bay in space and time. And where that's really useful is identifying like high risk areas. So you can really see at a fine scale where human activity might overlap with an important area for a species. And that can be really important for conservation management, but that's a whole nother talk and a whole nother use of data. With the marine discovery data, I've actually broken the searching effort down by sea states. So I talked about how sea state can affect detectability. Some species particularly are hard to detect in higher sea states. This is all of our effort, broken down by year. This is in sea state 4 and below, and then sea state 3 and 1 meter swell and below. So actually with porpoises, we only retain sightings and data that we collect in sea state 3 and below for analysis, because when the sea state gets above that, you find, although we can detect them in much higher sea states, the likelihood of missing them to detecting them becomes more of a 50-50. So that's where you take it out, because you're kind of then as likely to miss them as detect them. So it's affecting your overall results. So let's have a look at harbour porpoises first of all. So in the Sequest data, we see that there's this general increase. 2020 is grayed out because that's COVID. And COVID's really complicated because people were surveying at random times of year. There were lots of people looking at certain times of year and so on. And it really needs an analysis on its own to understand what happened in that year. But I have left it within the data. This data set does show that in 2022, it looks like there was a lot less, well, there were a lot less porpoises recorded for the effort. There was quite a lot of effort in 2022. But also, there were high sea states between really from August to the end of the year. And those high sea states can make it hard to detect porpoises. And actually, porpoise presence off the southwest is quite seasonal. There's a seasonality to it. May and June, there's a real dip, but then it builds, and in through the late summer and August into winter, we get much higher numbers. And if there are higher sea states when the higher numbers are around, then you're not going to be detecting as many as if it's a year with good sea states in those conditions. So it could be that that caused it. Also, there are a lot of common dolphins recorded in 2022, and we definitely see common dolphins displacing porpoises from their habitat. We've watched pods of porpoises herding up fish, only to have a big pod of common dolphins come in and basically steal them. So we find that when there are a lot of common dolphins around, it might displace porpoises maybe away from the coast. So there might be other reasons that explain that reduced sightings rate in 2022, but also it might mean that there were less porpoises around. This step shows where porpoises were sighted. So these are sightings per hour. The redder, the more sightings, although be cautious with the really red ones, because if you don't have much survey effort, which a lot of those red sites don't have, it doesn't necessarily give you a correct picture. If you happen to go there and see a lot of animals, it can really inflate the sightings rate. If you think about it with a six-sided dice, you actually have to roll a six-sided, if you roll a six-sided dice 100 times, you still might not roll a 6. But actually, the more you roll it, the more you increase your chance of rolling every number. Now, if you think about the natural environment, it's infinitely more complex than a six-sided dice. So in order to see everything that an area, every scenario an area could have, you need to visit that area a lot of times. So the more effort you have in an area, the more true picture you get. So in these maps where I'm mapping the sightings rates, the middle colors are the ones that probably are giving you most consistent results. So with the marine discovery data, we see a real consistency with porpoise sightings and very high sightings rate. The sightings rate in Mounts Bay is comparable to anywhere in the world that's considered an important hotspot for porpoises. I've got COVID grayed out. I've also grayed out 2018. 2018 is interesting. It looks like there's tons and tons. We saw loads of porpoises that year. But 2018 wasn't a particularly, it had a typical amount of effort through the whole year. But when I looked into it, what I found is between August and the end of the year, we had about 20% more effort in sea state 3 and below than all the other years. And if we had a normal amount of effort in the year, it means we have less effort in the time when there are less porpoises around and more effort in the time when there are lots of porpoises around. So that then skewed our results. So even when you've got the effort, you have to really look into it to understand what's going on with the data. And you can see how they're not having the effort. You wouldn't know that. So you think 2018 was a bumpy year, when in reality, it was probably actually a more like quite a typical year, a high typical year. But definitely we've got this real consistent trend of high porpoise sightings. With common dolphins, we've definitely seen increases. And really, since 2016, there have been consistent increases. And there's a high sighting rate again in 2013 on the Sequest data. This is where common dolphins are being seen by Sequest observers on their effort surveys. And in the marine discovery data, again, we can see at 2016, there's this real jump. So obviously we've got these peaks, this peak of 2017, 2018, I've kind of explained, because actually, again, all dolphin sightings show this seasonality where there's a bit of a dip in May and June. But 2017 actually was a really good year. And you may have noticed when I showed you our effort looked down in 2017. But that partly could be down to the fact that we were literally going from dolphin pod to dolphin pod to dolphin pod. So we weren't getting as far as we would normally be searching. Taking those out of the equation, you can still see on all the other years after 2016, our sightings rate has doubled and compared to some years before 2016, even tripled. So it shows this movement of common dolphin, or we're seeing more common dolphins closer inshore. Risso's dolphins are an interesting one. So sighting rates, we tend to have closer inshore, higher sightings in odd years. And the odds, so that's 2015, 2017, 2019 is down a bit on this. And we haven't got 2023 actually in the Sequest data yet, but 2023 was a really good year as well. And this fits in with the spawning of cuttlefish. Every 2 years they come inshore, and that happens to be odd years to spawn, and that's how it fits with their life cycle. And so what we're seeing is Risso's dolphins feeding on cuttlefish around the eelgrass beds. And you'll see the marine discovery data shows the same. This distribution of the sightings map probably isn't a true reflection, because we tend to get a lot of sightings across Mounts Bay and along the south coast of Cornwall all the way up to Plymouth. But it just happens to be that this is where surveys have seen Risso's. It shows the need to have lots of surveys and lots of areas to get a true picture, actually. And yeah, here's the marine discovery data. So 2015 was a bumper year for us, and 2023, the 2017, 2021 all fit this 2-yearly pattern. 2019 was down. I don't know if that was just a bad year for us recording, bad year for cuttlefish, or the cuttlefish were using other areas, not sure. Although one thing we do know is that with warming oceans, cuttlefish tend to, well, cephalopods, cuttlefish and squid particularly, lay more eggs, so they're more obvious. So warming oceans create better conditions, if you like, for squid and cuttlefish, and therefore potentially better conditions for Risso's dolphins. And Eddie's going to talk about Risso's in the Orca data. And what the Orca data shows is that in the even years, when we have not so good years for them, there are actually Risso's still around in the southwest. They're just a bit further offshore, so a bit outside of the area where we're surveying or where Sequest is surveying. And so that's starting to show us that there is this growing abundance, again, like the common dolphins, of Risso's dolphins in the southwest. Bottlenose dolphins are a trickier one, and Simon Ingram's going to talk in detail about bottlenose dolphins. So with bottlenose dolphins around the southwest, we see what we describe as inshore animals and offshore animals. They're the same species, but they behave differently. So the inshores typically are in smaller pods, stick very close to the coastline, track laterally along the coast, and feed on larger fish. And then the offshore pods, much bigger pods, and they tend to behave a bit more like common dolphins. So around Cornwall, we know we're seeing the inshore dolphins much less in the summer. We used to see them all the time. They do turn up more in the winter, and they're probably showing up here in the Sequest data. But where we have these big spikes of lots of dolphin sightings is probably where offshore pods have been recorded, because there might be 5 or 10 times as many individuals in an offshore pod compared to an inshore pod. So a few offshore encounters can really skew your data up. And we can see bottlenose dolphins really recorded around the whole coast and Sequest surveys. And again, the marine discovery data, really in recent years, the animals we've been recording have all been offshores. Without photos and photo ID, it's impossible to tell, but we know from our photo ID work, or from the photo ID work of the Bottlenose Dolphin Consortium, that the ones we're recording are offshores. 2018, again, looks like a big year, but potentially that's where we just recorded some of these big offshore pods a few times in a row, and that skewed the data up. Pilot whales, we don't actually have much pilot whale data. I've really put this in because this is a great picture, but also to illustrate the point of, with some species, we just don't have enough data to start analysing. We're probably out of typical pilot whale habitat, really closer inshore. But it's the same, we don't have enough data for striped dolphins or white-beaked dolphins to do effort-based analysis. So Dan's going to talk about the baleen whales, but I just thought I'd put in some of the effort sightings for the baleen whales just to see what's going on there, because it tells a similar story to the common dolphins, in that we're seeing a lot more of them closer inshore. We can see this in the sequest data. And interestingly, minke whales here are being recorded for all the survey sites around the coast. And we also see it in the marine discovery data. So here we have 2017 again, which was an incredible year for wildlife. 2018 got skewed up probably because, I said about the surveying effort in autumn and late summer and autumn. And also higher sea states can make minke whales tricky to detect. So having that year where we had lower sea states made them easier to detect. But again, you can see after 2016, really our sightings rate is doubling or even tripling. So why are these animals suddenly short? Same thing happens with fin whales. So I haven't got in the effort data I've got so far up until 2022 for sequest, there aren't any fin whales recorded in the effort surveys. But 2023 will change that when we get the 2023 data. But we can see again, since 2017, this is summer recordings. Fin whales have always been recorded in various numbers in the winter, particularly just this side of the Isles of Scilly. But we're seeing them increasingly closer inshore in the summer in more numbers. This brings me on to humpbacks. So humpbacks are interesting because they're turning up in big numbers in the winter, which actually they shouldn't be. Adult humpback whales in the winter should be migrating. And if they're not migrating, it means they didn't get enough food that summer to make the migration. And we're increasingly seeing them. Well, 2020, 2021, great years for them. 2022, I talked about the weather in 2022. Towards the end of the year, it was very poor for spotting. So we might find it's when the humpbacks are close inshore. In the winter, it tends to be from just before Christmas, then into the winter months after Christmas. So we might find 2023 is it will be a really bumpy year because it's been really good for sightings this year in the winter. But actually, in January and February of the year, it might account for some of the winter sightings as well that would be linked to the 2022 winter. This map isn't really representative because the humpbacks are being recorded all around the coast now, and I think updated data will change the map. These marine discovery sightings are actually, we only really operate too much in November. It's a limitation of our data, but not actually going all year round. But these are, when humpbacks should be on the northern feeding grounds in the summer months. And actually, we've been seeing them right through the last 12 years. So that humpback issue brings me on to what can this tell us about the wider health of these populations? Well, we have to be cautious with anything we interpret from the data, and it would take a lot more looking at to fully understand. But if we look at the literature, we look at publications from other people. So we take Angus Atkinson from PML, he presented last year at SWME systems on plankton and changes in the plankton structure. And that video is online. I recommend watching it if you haven't seen it. But what we're seeing is less nutrient availability in the Northeast Atlantic. And actually, we've recorded a decline in nutrient availability since the 70s offshore in the Atlantic because of warmer conditions, stronger stratification, preventing the nutrient-rich water from reaching the surface. And then we now have the drought in France, which is affecting the river flow for the main rivers out of France, and that's where most of the nutrients for the Northeast Atlantic come from. We don't really have wind-driven upwelling along the Biscay Shelf because the wind's in the wrong direction. Actually, prevailing wind directions favour downwelling. There are local exceptions to this, and there are tidally driven upwelling areas, but predominantly the productivity of the North Atlantic relates to where ocean water meets this coastal river water. So the nutrient-rich river water, and along those boundaries, the phytoplankton and the zooplankton build. And where we've got less nutrient availability, that nutrient availability is contracting onto the continental shelf edge. So where the tide flow and the tide turbulence can reach down to the seafloor, which with tidal flow rate in the southwest typically between 40 and 60 meters, and also where wave turbulence, so from typical swells in the southwest, again, that really from like 40 meters to about 60, 100 meters, it can cause turbulence and stir up nutrients. So there are more nutrients closer inshore, and that could account for why we've got this shift of animals inshore. Also, possibly a northward shift as well, because again, Angus talks about this change in plankton structure, and actually the plankton is becoming less nutritious. So at the bottom, we've got typically diatoms. The diatoms are being taken over by cyanobacteria, which are much less nutritious species. And so there's less energy basically passing up the food chain. And this could then, obviously this is being affected by warming oceans as well. So this could be causing a bit of a northward shift, but it's not as simple as a straight northward or coastal shift. But what we're seeing is this coastal movement, with probably linked to the higher nutrient availability on the shelf edge. The other thing I wanted to quickly talk about is what can we learn from other studies. So in between 2012 and 2016 in the Pacific, they had a very similar thing to we're having, with this big movement of common dolphins inshore, this year-round presence in places like Monterey Bay of humpbacks, so the humpbacks weren't migrating. And this recent study has come out, it's linked on this page as well, that showed that in that period between 2012 and 2016, 20% of the humpback whale population starved. And they weren't migrating as they would normally migrate. And if humpback whales aren't migrating, they're not having calves. And so that means their birthing rate is going down. So their overall population is suffering too. Interestingly, in the paper, the humpbacks that migrated to Hawaii suffered more than the ones that went down to Mexico. But what we're seeing potentially is a mirror of that in the Atlantic. And so, these large numbers of common dolphins inshore and humpbacks in high latitudes when they should be down south breeding. So, last slide, I know I'm over my time. Implications of this. So, this habitat compression, if we are seeing habitat compression of common dolphins into a smaller area, well, firstly, offshore where they normally were, there's more competition for less resources, and that's potentially contracting their habitat over the shelf area, which then is pushing more competition for less resources or a smaller finite amount of resources on the shelf edge. So that means they're then under more pressure. Equally, by pushing them inshore, it means there's a greater crossover with human activity, with anthropogenic activity, so greater potential risk of bycatch, implications of pollution on fertility rate and birth rate, and then disturbance. Obviously, dolphins around encourages more people to go out. We've seen the boat trip businesses explode in Cornwall, and no one's really regulating any of this. And then again, competition for resources between these animals and humans. So they're under natural pressure, but also then equally under increased pressure by being pushed in closer with humans. Anyway, that's my take on what's going on, and thanks for listening.
Brilliant, thank you, Duncan. We're now going to hear from Ellie Kepi from Orca. Unfortunately, Ellie couldn't be with us this evening, so we've got a video instead. So I'm just going to share my screen and hope that it works.
Hello. So following on from Duncan's talk, I'm going to be talking about what Orca's data shows for the same time period that Duncan was looking at, to see if we can draw comparisons between inshore and offshore. So at Orca, we collect data from platforms of opportunity, mainly ferries and cruise ships. So these are just vessels that aren't dedicated cetacean research vessels, to get an idea of cetacean abundance and distribution at kind of finer temporal scale than dedicated surveys can achieve because of cost and things like that. So this is a map of our ferry routes, just to give you a bit of context. We'll either have volunteer marine mammal surveyors conducting line transect distance sampling surveys from the bridge, or we'll have ocean conservationists collecting data in the course of public education activities from ferries and cruise ships. And so this is an actual distribution of our survey effort, and the more red it is, the higher the survey effort. And you can clearly see the ferry routes are the really red areas, and the lighter bits will be where the ferry's gone a slightly different way than it usually does, and the whiter bits mainly represent cruise effort, which can be more variable. It depends on the itinerary, so it's a little bit less repeatable than the ferry survey, but it still gives us an idea of what's happening out there. It's also important to think about the survey effort in time too, because it's actually gone up a lot over the years. So at the very start, in the first 3 years, we only had the odd cruise, and it was just the distance sampling surveys from the ferries that were being done. And then in 2014, wildlife officers, which are now called ocean conservationists, started to collect effort-based data from ferries. So the effort kind of tripled in that year and stayed more or less the same until 2019, when we started having more cruises. Big drop in 2020 due to the pandemic. I think we had maybe a few cruises before everything got shut down. So anything in that year should be interpreted really cautiously. And a little increase in 2021, when it was mainly effort from cruise ships on British Isles itineraries, and 2 of the ferries had ocean conservationists on board in that year. So the effort in that year, like I said, was a bit more inshore than normal. So it's important to bear that in mind when interpreting the results for each species. In 2022, we were more or less back to normal in the southwest, and then in 2023, we had a few additional observers on a few additional ferries collecting that data nearly daily. so effort had gone up quite a bit in that year. So moving on to species-specific findings, we'll start with harbour porpoises. So bar a few fluctuations, like a bit of a spike in 2016 and again in 2018, it looks like the trend has been for decreasing harbour porpoise sightings rate, so that's the number of harbour porpoises per 100 kilometres of effort. But there are a few reasons why this might not necessarily represent a decline in harbour porpoises in the southwest. For one thing, it might just mean that effort has increased in the whole area, as in it was a big broad area that I showed you, but it might not have increased in good harbour porpoise habitat, for example. And I also haven't accounted for sea state. Harbour porpoises are really difficult to detect once it gets a bit choppy because they're so small and they're so subtle, they don't jump out that much. It's really easy to miss them. For example, in 2022, there were a lot of storms in the late summer and autumn, which will have really hampered our ability to detect porpoises, even if they were really there. And if they've maybe increased further inshore, it might be that we just don't see them as much offshore. So that's why it's really important to kind of combine these data sets to get a better idea of what's going on. And I thought it would be interesting to talk about the distribution as well. So I have the same 5 kilometre grid as before, and again, the redder colours indicate more sightings rate, with the sightings rate being sightings per 100 kilometres of effort. So with harbour porpoises, there's a few interesting patterns. So sort of around headlands here, here, and here, the sightings rates are quite high. What's particularly interesting about this one is that this is along the Selonian route, which the surveys are conducted twice a month between March and November, and it's still pretty red despite really high survey effort. So that might indicate it's consistently a good area for porpoises. We can't really say the same for here and here because we don't really have the repeated survey effort. But it could be that these areas create good feeding habitat for porpoises. They need predictable feeding locations because they have such high energetic requirements, and the tide is really predictable, as you probably know. It goes in and out every day, and is really easy to predict. And when it interacts with these kind of features, it can aggregate prey and create feeding opportunities. The common dolphins show sort of the opposite trend to harbour porpoises, with a general increase over time. Again, I would ignore 2020 since we didn't really have a full year of surveying, so it's not very comparable with the other years. And the really interesting thing is that the sightings rate is still really high despite all this effort, which again might be pretty good evidence that they really genuinely have increased in the southwest over time, which is interesting. There's also a little spike in 2013, which also exists in the minke whale graph I'll show in a little while, which is also interesting. Maybe if they share the same prey or similar prey that had a really good year that year, there could have been an increase. Who knows? Very interesting and worth looking into some more. In terms of distribution, they're pretty much well, not everywhere. There's a lot of white on there. The interesting thing is that there's less red further to the east, although we have seen an increase on the ferry routes in recent years. But it's just not comparable to how many there are further west here. They're seen all along the ferry routes leaving Plymouth, all along the Selonian route, and all the way all here on the kind of deeper waters of the shelf. And the Western Channel and Celtic Sea tends to be partly stratified in the summer, spring and summer, and there can be tidal mixing fronts. There's one that kind of forms along here over to France and around here too, that can be really productive feeding areas for common dolphins. That's one possible explanation, but we don't know for sure, and it would need to be looked into. So bottlenose dolphins are a lot more variable. There's no clear trend as far as I can see. But the interesting thing with this is that there's a big spike in 2018 that was also evident in the data that Duncan was showing. And there's also a bit of a spike in 2021 when, as I said, the survey effort was a bit more skewed inshore in that year. But we can't really tell from this whether they were seeing more of the inshore dolphins or offshore dolphins in that year without different data like photo ID and things like that. but it's an interesting pattern, and it's interesting how variable it is, and it would be really interesting to look into what drives it. In terms of distribution, it's a lot more scattered than with common dolphins. They're seen more or less all along the Sloanian route, and scattered along the ferry routes leaving Plymouth, and also offshore in the channel here and over here. I'm not really sure what could be going on out here. Again, this bit could be quite productive in the summer months, but yep, again, could do with looking into to find out what's going on. Now for my favourite resource dolphins, as Duncan has said, abundance can vary quite a lot between years, and this is because they feed mainly on cephalopods, which are really sensitive to changes in the environment, and they're predicted to reap the benefits of warming oceans because, at least sort of up to a point, it benefits their growth and metabolism and survival. So they should increase, and they seem to already be increasing in some places. So we might expect results to increase overall. But the Orca data shows a more variable picture for now. Interestingly, it shows kind of an opposite pattern to the marine discovery data. So in 2018, they didn't see that many, but it's the third biggest year in the Orca data. And again with 2011, they didn't see that many with marine discovery, but it's the biggest year in the Orca data. So it could be that they're just offshore in the years that marine discovery aren't seeing them, which again kind of highlights the value of having data further offshore. So you can kind of piece together things about movements and changes between years. I will say that despite 2023 seeming to have a low sightings rate, it's actually, in terms of raw sightings, it was one of our biggest years yet for results in the southwest. In terms of distribution, we see them all along the Sloanian, including right here inshore, which is consistent with what marine discovery see in here, but we also see them in this area offshore Plymouth. It's kind of masked the seasonality because they tend to see them here sort of in the late summer and autumn, and also off here at the start of the season in March, April time, and they tend not to start to pick them up until late April, May on the Sloanian route. And cephalopods do migrate. Cuttlefish in the English Channel will move offshore in the winter and then come back in the spring and summer. And there's a squid species that migrates east to west through the English Channel, and that migration has been found to be related to temperature and the North Atlantic Oscillation. So this could all affect when and where we're going to see rizos. Pilot whales, another cephalopod feeder, again, really variable. Some years we haven't recorded them at all, and some years we've seen lots of them, but you can see from the values on the y-axis, the sightings rates are a lot lower than for rizos. So the maximum for rizos is 0.08 per 100 kilometres, but for pilot whales it's 0.015. So again, this is a map of the distribution. We see them occasionally on the Sloanian route, and occasionally, again, this is mainly in the late summer and autumn that we pick them up from the ferries leaving Plymouth, and a few cruises that come through this way also pick them up. Again, possibly they could be feeding on squid and things that are coming back to go west to go and spawn. But I'm not sure what they eat in the off the southwest, but that's the kind of thing we would need to understand to try and get a better picture of what's going on with pilot whales, because obviously coming into shallow waters is going to bring them in closer contact with us, which threatens them. So minke whales, thanks to Duncan for this minke whale picture. So again, minke whales are really variable as well. Here's that spike in 2013 I mentioned that matches the smaller spike for common dolphins. So that's really interesting, and it just goes to show the variability inherent to marine ecosystems, that there can be these kind of massive changes in abundance, and that's why it's really important to collect a lot of data to be able to disentangle these from like changes due to an actual decrease in the population. But overall, it would seem that sightings rates have gone down in recent years. As for why, again, it might just be that maybe as our efforts expanded, maybe it's more offshore or away from areas that are good for minke whales. Minke whales, again, like porpoises, they're going to be tricky to detect in bad sea states since they don't jump out a lot. They are much bigger, but they're still quite subtle. So it could be that maybe in where the weather's been a bit windier in recent years, we aren't picking them up as much even if they are there. It's hard to say. It's definitely worth looking into some more, especially as they seem to have increased inshore from what Duncan was saying. In terms of distribution, we see them a lot on the Solonian route. Again, we have high survey effort, but we especially tend to see them in this kind of deep middle bit offshore, which is quite interesting. And we also pick them up sort of out further west here, out on the sort of deeper bits of the shelf. Kind of the same area we tend to see fin whales, as we'll see in a minute. But we do pick them up offshore in the channel as well. Again, we don't really know that much about minke whales, but in the southwest, but in other areas it tends to relate to feeding opportunities, because of course their feeding strategy is very expensive for them, and they need to kind of have sufficient densities to make it worthwhile to feed that way. So fin whales, we didn't really record them much at all around the southwest until 2018, and then they increased again in 2019. Hard to say what 2020 would have been like, but then again in 2021, and then again in 2022 they increased, and then it dropped again in 2023. So something important to bear in mind with the fin whales is, as Duncan will have said, the sightings around the southwest tend to be more in the winter months, and our data collection only takes place sort of, well, not only takes place, but mainly takes place from sort of early spring to late autumn. So you would kind of miss that in our data. So if there's, this could explain any discrepancies between the two data sets. In terms of distribution, again, we don't see them very often, but when we do, we've seen them a few times to the east of the Isles of Scilly. So a tide coming in can kind of create a wake behind islands, which can create feeding opportunities that are good for whales. But we've also recorded them off here, and also around here, so sort of further offshore. And again, in sort of the same, not exactly the same, but in the same general area as the minkies over here and over here, which is not quite southwest, but I guess it gives a bit of context to what Duncan's talked about already. That's all I have to say. I hope it was interesting. If you have any questions, feel free to email into Orca, and I'll try and get back to you. Thanks for listening. Hello.
Okay, so that was Ellie Kepi from Orca, who unfortunately couldn't be with us this evening, so that's why we were showing the video. So we'll quickly move on now to Dan Jarvis. This is his first talk, he's doing 2 this evening, and this one is with his Cornwall Wildlife Trust hat on. So I'll pass over to you, Dan.
Okay, thank you. I'll just share my screen. Can you just tell me that it's come up okay, please, Lauren?
Yeah, we can see that.
Okay, lovely. So this is a fairly brief talk, so I'll go quite quickly. This is the summary of the baleen whale sightings, and then we'll move on to the humpback whale identifications from 2023. The data in here, I would caveat, is nowhere near as advanced as what Duncan and Ellie have presented. There's a lot of ad hoc public sightings data that is included within this data set, but I do split it off into 2 separate sections. This is the first one, which is our longest data set that we've been using for the Southwest Marine Ecosystems report, which is from Cornwall Wildlife Trust and ERCIS, which is the county recorder for wildlife in Cornwall and the Isles of Scilly. In more recent years, we have added newer sources of data, which have made it harder to sort of compare those years. So we're continuing to just split them at the moment, so it's easier to draw out conclusions from them. So the top chart here on this slide shows just the raw total annual number of sightings. That's just from the CWT and ERCIS data. So you can see that from sort of 2018 onwards. So the chart at the top here, sorry, just to reiterate that bit then, that shows the CWT and ERCIS data going back to 2009. You can see that from 2018 onwards, it started to have a little bit of an uptick, and then 2020 onwards, quite significantly so. The bottom chart is the total sightings, so the same type of data, but from across all of the data sources that were available to us. which starts from 2020, which is more comparable as a subset on its own, although it is a larger data set, of course. The majority of the driving force behind the increased sightings being reported were the humpback whales from sort of 2019, 2020 onwards. But 2023, generally speaking, was consistent with the new normal baseline for the total number of sightings that we are receiving. As I was saying, minke whales, if you look at the top chart there, for 2023, there was actually almost a 50% drop in the number of reported sightings. And it's not really clear why, but when you take into account all of the data sources on the bottom chart, that actually reduces down to about 31% drop compared to previous years. So possibly isn't as significant as it might sound from the first chart. So that does need a little bit more looking into to understand the reasons why that has happened. But what's worth just noting on the bottom chart in particular is that humpback and fin whales seem to mirror each other quite closely in their visit behaviour as well, which is quite interesting to see if that trend continues in the future. Next slide, please, Lauren. Okay, so looking purely at the minke whales, there were a total from all data sources of 97 sightings. What was interesting to note this year, you might see from the chart in the yellow line, is that there was no corresponding peak in April and May, as there have been for the previous 2 years, which seemed to be starting to indicate a trend of a small springtime peak for sightings, then a big dip in June for unknown reasons, and then a more significant peak through the summer months. What's worth noting in 2023 is that there was a significantly big peak in August, but that the 2 months either side were quite low in comparison. So it seemed like we had a fairly short but very intense summer for minke whales, but they were late to arrive potentially and quick to leave again. Which possibly might be an indication of what food sources might have been available to them at the time. Most of the sightings were distributed around the west of Cornwall, but there were sightings also from Padstow and other places like Newquay Bay, all the way around to Falmouth Bay. And over at the Isles of Scilly, the majority of sightings seem to come from the eastern region of the islands. There was one sighting each from Devon at Berry Head, and a place called Tillywim in Dorset. Most sightings were of lone animals, but notably in July, a group of 6 were observed at the Isles of Scilly as well. Next slide, please, Lauren. Sei whales, we can pretty much skip through this very quickly. There were no sightings in 2023. The last time one was seen in the southwest that was positively identified was in 2021. And a single sighting as well in 2020, interestingly both in June off Padstow. Of course, we do have to take into account the potential for misidentification with fin whales or large whales that have been seen but not identified as either fin or sei whales. So the question is open whether that might be a contributing factor, as well as whether these are species that are further offshore, if they're using different habitats potentially at different times of the year. It's a little hard to say one way or the other on that. Next slide, please. For fin whales, we had a record from overall data sources of 62 sightings across the southwest in 2023. The trend of having peaks in winter and summer continues to be upheld, and there was an exceptional record in August of 18 sightings. Which is the most we've ever had in a month that's been recorded from this data set here. Winter seems to correspond with the presence of the humpback whales. Sorry, I should say that in summer with minke whales, and then in the winter with the humpback whales as well. So August being a record for both minke and humpback whale sightings seems to indicate it was an especially productive month for them. Most of the sightings came from the south coast of Cornwall and the south and east areas of the Isles of Scilly. And one offshore survey that we have data from recorded on one day group of 2, a group of 3 and a group of 6 during September. So potentially there is some offshore activity moving into the autumn as well as they move away from the coastal areas in summer. Next slide, please. For humpback whales, another record year overall for them with 73 reported sightings. The winter peak is upheld with January, February and December all being the most notable months for them. And the hotspots this year seem to be St Ives Bay, Newquay Bay and the south and east areas of the Isles of Scilly. So again, that's really coming up quite often now amongst all the baleen whales that this might be a significant habitat for them in that region for different times of the year. There were sporadic sightings in other places, including Crackington Haven and around into Falmouth Bay. Mostly lone animals, but occasionally pairs were seen as well. And from the photo identification work, we know that in 2023, we had 11 different whales known to have visited. But of course, this is likely to be higher from whales that were never identified due to a lack of available photos as well. So we're going to move on now, please, Lauren, to look at our humpback identifications in 2023. We'll go quite quickly. This one is Snowy, recorded on a couple of occasions at the Isles of Scilly. This whale presumably was actually around for most of the winter, but was only recorded from identification photos on 2 occasions. So it potentially was around a lot longer than we have recorded, but it just wasn't able to be identified to confirm that. Next slide, please. This animal was called Sennen. It was seen in the area of Sennen and also moving into St Ives Bay over the course of about 2 weeks and then back again towards Land's End during January of 2023. Next slide, please. On the same day as one of the Land's End sightings, we also had this animal sighted just south of Land's End. And one might be forgiven for thinking it was probably the same whale had we not had photos of it, which proved it was in fact 2 completely different whales that we had on that day. This animal was sighted a few times around January and February. Next slide, please. Moving into the summer, we had this whale sighted in June in Falmouth Bay, showing its flukes quite well. This is a fantastic photo from of ocean sailing. Next slide, please. It was only seen on that one occasion there. And then 8 days later, another whale was seen further out in Falmouth Bay, down towards the Menacles Reef. And once again, through photo identification images, we were able to confirm that was 2 completely separate animals and not the same animal that had been hanging around between Falmouth and the Lizard for a week or so. So this is why we have to be careful with photo identification and matching sightings to each other. We can't just assume that the same whale seen in the same area on the same day or over a few days is the same whale, because they do seem to be quite sneaky about moving in and moving out again and being in fact different whales too. Next slide, please. Also in June, a little bit later on, we had this animal photographed off Pentire Head on the north coast. We haven't been able to match it to either of the 2 previous whales, so it could still potentially in the future be matched to one of them, or it could be another completely different whale. Jury's out on that one. Next slide, please. This one's a little bit outside of the area of southwest marine ecosystems. This is actually over at the Channel Islands between the islands of Jersey and Guernsey. This was another summer visitor that was reported to have a second, much smaller whale with it. We're not sure if that was meaning a mother and a calf or just an adult and a juvenile. But we have no photos of the second animal. This one here is the larger of the pair that was sighted here. Next slide, please. We then come into the winter. At the beginning of December, this animal was photographed by Will Brewster down off Cape Cornwall breaching. These are the only photos we have of this animal that we can get decent ID imagery from. And unfortunately, we haven't been able to match it to any of the other winter visitors that we've had more recently. So again, there's still a possibility this could be one of those, or it could be another completely different animal. Next slide, please. This animal here was first sighted in St Ives Bay during mid-December, and was named Ivy. It's been seen on a few occasions, including up at Newquay Bay. Next slide, please. And then we move on to Minstrel, who was seen at a similar sort of time in December, starting off this time in Newquay Bay, but then moved to St Ives Bay over New Year, and has been seen several times since in 2024, but that's spoilers for next year. Next slide, please. So thank you to all the contributors who have sent in data or assisted with photo identifications, and of course to everybody who has sent in photos or videos for us to use for the humpback whale identification catalogue here for Southwest England. Thank you to Duncan, Lauren and Bob behind the scenes for getting this webinar organised, and the Southwest Marine Ecosystems Conference overall organised as well. And once again, a shout out for anyone that has videos or photos of humpbacks, no matter how long ago or whatever body part it is. We'll give it a go. Please do send it in. There's my email address. Thank you very much.
Thank you very much, Dan. We've got one more talk before we're going to have a little break. So I'll hand over now to Beth Harvey from the University of Plymouth.
Hi everyone, just let me know in a sec whether the screen is showing.
Yeah, we can see that.
Yeah, brilliant. So hi everyone, my name's Beth. I'm from the University of Plymouth, where I'm doing a PhD, so I'm in my first year, and I'm looking at the abundance and distribution of cetaceans in the Western English Channel and exposure to key threats. So that's with Simon Ingram and Claire Embling at Plymouth, and also Ros Putland from CFAS. So I'll start with a little bit of background. We've heard a bit about the cetacean species in the area already, but I'll talk a bit about threats and also some knowledge gaps, which I hope to fill during the course of the project. So these are the most commonly sighted species in the southwest. There are 20 species or so which have been seen generally, but most of these are vagrants. So these are the most common, and out of those, harbour porpoise make up around 60% of sightings as of 2014, and common dolphin are also really frequently seen. So the area has been identified as a biodiversity hotspot, and within the English Channel and the southern North Sea, the Western English Channel is particularly important for dolphins, with 95% of dolphin sightings there. Within the southwest, the south coast of Cornwall has been identified as important, with higher numbers of sightings for both porpoises and common dolphins. So we've just heard about the baleen whales in much more detail, but there seems to have been an increase potentially in the last few years, especially in the Isles of Scilly, and certainly there's been a lot of recent publicity about them. So what are the current data sets? We've heard about Orca already and marine discovery, so I'll just briefly talk about them. So there's effort-based ferry surveys like Orca, wildlife tour operators, which is boat-based citizen science. There's scientific aerial surveys, land-based observations like Sequest, Southwest, and of course strandings data as well. And these complement each other pretty well, but there are a few weaknesses in terms of lacking either spatial coverage or perhaps their snapshots in time, like the aerial surveys. They're not always effort-based, so Duncan nicely described effort there, so I'm not going to go into it. Or in terms of land-based observations or strandings, it lacks that at-sea data. So there is room for some more data collection. In terms of increasing the spatial coverage and having annual data recording, as well as doing effort-based surveys in the southwest. So what are the human activities in the southwest? There's a lot of shipping activity. The channel itself is one of the main shipping channels in the world. And there's also a lot of recreational boat activity as well, especially in the summer months. There is a huge amount of fishing activity in the southwest as well, It's mixed fisheries, so there's potting, trawling, netting, dredging, and you can see in that middle picture that it's quite high intensity in the southwest. Offshore as well has been marked for future renewable development, which is something to keep an eye on. So the southwest is generally quite highly impacted by human activities. And this causes a few problems for cetaceans in the southwest. So I've named a few key threats here, and I'll be focusing in my PhD on underwater sound and also entanglement and bycatch in fishing gear. So a bit about underwater sound. The ocean is a really noisy place. So there's both natural and anthropogenic or human-made sources of noise. So human-made can be shipping, seismic surveys, pile driving and construction, that kind of thing. And natural sources can be anything from earthquakes and waves to animals making noises. So sound is really important for marine animals, and particularly for cetaceans as they echolocate, and they'll use sound for communicating with each other, for finding prey, and also for navigation. So it's a really important sense. At its very worst, that sound can cause injury or death to cetaceans, particularly impulsive sound. So for example, seismic surveys. At a slightly lower level, it can cause hearing damage and mass communications. So there's reduced communication space between individuals of the same species. And it can also cause changes in behavior. It can reduce their foraging and ability to find food. It can increase their general stress levels, and all of those things can have an impact at the population level. Bycatch is also an issue in the southwest. This is a bicorp harbour porpoise, and it's in fact one of the greatest conservation threats to marine mammals globally. And it certainly is an issue in the southwest, not just in terms of conservation, but in terms of welfare. So there's a couple of knowledge gaps which I'm hoping to fill. So I'm looking into where do human activities and cetaceans co-occur in the southwest, and how much noise are cetaceans exposed to. Which brings me on to the aims of my PhD. As it stands anyway, this might change a little bit as I go through. But firstly, I want to answer fundamental questions about the abundance, distribution and habitat preferences of cetaceans in the southwest. I then want to analyse the soundscape of Plymouth Sound and assess exposure of cetaceans to shipping noise throughout the area. And finally, if there's time, I'd also like to look at other key threats such as bycatch. So the University of Plymouth has been running visual and acoustic surveys for cetaceans on board the university yacht Take the Helm since 2017, and that's been every year apart from 2020 for obvious reasons. So that's visual surveys, but also towing a hydrophone about 100 meters behind the boat. And this shows where the surveys have taken place so far, over 47 days in the summer months, and we've covered over 3,500 kilometers of survey effort. And it might look like squiggly lines, but what we're trying to do, it's hard while sailing, but trying to do zigzags to up to around 6 nautical miles from the coast, obviously weather permitting, and we'll go as far west as possible. We have made it to the Scilly Isles twice so far. So Plymouth has also been part of the UK Noise Monitoring Network since 2019. And at the mouth of Plymouth Sound near Ramehead, there's been a sound trap in collaboration with CFAS since 2019. Since last year as well, in the same location and in the same picture, you can see there's a F-pod, so that's a click detector for cetacean echolocations. So I'll talk a bit about preliminary results. Like I say, I'm still fairly early into the PhD, so take everything with a little pinch of salt. This is all ongoing work. But just the first look at just using the visual data from the Take the Helm surveys, what you can see is the total number of individuals from all of the surveys, and it's easy to see that common dolphins are by far the most frequently seen on them. Harbour porpoises as well are pretty commonly seen, and we've seen 4 of the other species which are much less frequently seen so far on the surveys. So I did look into any changes over time, and like Ellie, I've looked at the number of individuals seen per kilometre of effort to account for different effort in different years. But with harbour porpoises, what I've not done yet is looked into the sea state or the weather, which can really heavily influence the number of sightings. So it looks like harbour porpoises have declined here, but yeah, definitely take that one with a pinch of salt. But it is interesting that we've seen the most common dolphins in 2023 and none in 2017. The other species are all at such low levels, really, that you can't see any trends in them. But we didn't see bottlenose dolphins at all until 2022. What's potentially more interesting is their spatial distributions. So this is harbour porpoise sightings, and again, it's effort corrected. So each grid cell is the number of sightings per kilometre surveyed within that grid cell. And you can see that they're predominantly a near coast species, and there's a hotspot around the eastern side of the Isles of Scilly potentially, which is quite interesting. This is common dolphins, and you can see that they're a bit more spread away from the coast. They don't have that hotspot around the Isles of Scilly, but in the waters between Isles of Scilly and the mainland, there have been higher sightings. But like I said earlier, we've actually only managed to make it over there twice. So we hope to get over there more, as the more times we go over an area, the more reliable the data. And these are the remaining species, so minke whales, none of them have been seen very frequently. Minke whales have been seen both inshore and a bit further offshore. Bottlenose dolphin sightings were spread pretty evenly along the coast. Rissos dolphin sightings were all within a fairly small area near Falmouth Bay, and there's only that one of white-beaked dolphins. So you can't really tell very much from these as we haven't seen them frequently enough, really. So I'm going to present a little bit of work by Hayley McLennan, who did at MRes at Plymouth. And she just took a first look at the acoustic data from the Take the Helm surveys. And she was looking at harbour porpoises and modelling their presence based on different environmental variables. So this is just a comparison of visual and acoustic detections of harbour porpoises. So those little black dots are either sightings or acoustic detections. And it's really easy to see that using acoustics greatly increases the chances of detecting porpoises. Like Ellie mentioned, they are really quite tricky to see, especially when there's higher sea states. So it just shows the value of using acoustics for surveys as well. And she looked at environmental variables and found that sea surface temperature, or SST, distance from the coast and depth were related to porpoise presence. And then she created a model and mapped the probability of porpoise presence and found that shallower near coastal areas are really important for harbour porpoises, which is probably what we would expect. So just the first look at the noise monitoring. Generally, noise has been lower in the Plymouth Sound recordings than predicted by UK-wide noise propagation models by CFAS. So we need to look into that a little bit more, and we're not sure why. The graph I wouldn't pay too much attention to, but it's basically different months and frequency along the bottom and noise level along the side. And it's basically showing that the lower frequencies, which is where you might find shipping noise, you tend to have a higher level of noise. But there's that bump in the middle, in the mid frequencies, which again, we're not quite sure why that's there. So we need to look into it again a bit more. But in the recordings, we've had detections of dolphins, minke whales, and other varied animals, which is quite interesting. So for example, a minke pulse call in the lower frequencies there, also some snapping shrimp, and dolphin whistles as well. So what's next in the project? So I don't know what's happened to the, oh, there it is. I'm going to take a greater look at the Take the Helm survey data, both visual and acoustic, to do distance sampling. So to basically take account of not only where the animals were seen, but how far away from the vessel they were, and therefore the probability of detection, and also take account of other variables like sea state, weather, glare, that kind of thing, which all impacts the probability of detection. So I'm going to do a more sophisticated analysis of the data that we've got from the Take the Helm surveys. And then with that data, I want to do habitat modeling, so correlate that abundance with different environmental drivers, such as depth, sea surface temperature, or tidal currents, for example. So I also need to add acoustics. I've just taken a little look at the visual data so far, but Haley's analysis has shown how valuable the use of acoustics will be. And I need to do a proper analysis of the sound trap and the FPOD in Plymouth Sound. That's a lot of data. So I'll be looking into the use of AI, or automated machine learning, which can hopefully automatically detect dolphin whistles, for example, within that really big data set, because like I say, it's been recording continuously almost since 2019. So lots of data. I'd also like to finally analyse the threats. So once we know more about the abundance and distribution, then we can overlay that with different threats such as shipping, underwater sound, or fisheries, for example, vessel monitoring systems which track vessels. Finally, there's other possibilities in the future. So this year we're looking to expand the surveys and actually go to the east for the very first time. So we'll see what we find there. There's the possibility of incorporating those other data sets mentioned and possibly collaborating with people. And also, I think there's going to be a talk on this, but there's increased acoustic monitoring of cetaceans at different sites throughout the Southwest. So this might be beyond the scope of the PhD itself, but that's definitely an interesting one to keep an eye on for the future. So watch this space. I'm doing part-time PhD, so I'll be around for 5 years doing this. So if anyone has any questions, comments, ideas, or would like to collaborate in any way, then please do get in touch. That is my email down there at the very bottom. I'd love to hear from you, but otherwise, thank you very much.
Thank you, Beth, that was great. Okay, great. Welcome back, everybody. We'll get straight back into it. Our next talk is from Joe Dennett from Chelonia. So I'll pass over to you, Joe.
Thank you. There. Are you seeing my full frame slide there?
We are, yeah.
Great, good. Okay. Well, thank you for inviting me. I'll start off by doing a bit of background on the CAT project. It was proposed by Chelonia based on similar large-scale deployments of pods in the Baltic and the Black Seas. With FPODs, we specialize in the study of ultrasonic click trains recorded with FPODs rather than the lower frequency cetacean whistles most people are familiar with. The UK version of this project, CAT, was designed to put FPODs and FPOD data into the hands of local marine groups and citizen science volunteers that would not normally have access to this technology. That worked very well in the first year, and then progress really accelerated quickly when CAT started collaborating with some existing projects and organisations with marine structure already in place around the sea. So the initial phase was centred around Cornwall and the Wildlife Trust affiliated marine groups. Through these connections, we started collaborating with the Fish Intel project at the Universities of Exeter and Plymouth. FPODs pick up everything between about 17 kilohertz and 220 kilohertz. The fish tags used by these projects are 69 kilohertz. So we pick up those quite effectively, and we were in a position to maybe add some detail to these projects and at the same time share some of those sites and extend our monitoring capabilities as well. We added a lot of existing and new data by collaborating with the Channel Islands. Nikki Harris down there on the Dolphin project introduced us to the governments of Guernsey and Jersey, where they have been monitoring cetaceans with CPODs and FPODs for several years. So that was a big step forward for us. More recently, I've sent some FPODs to Natural Resources Wales and the Welsh Wildlife Trust for sites around Pembrokeshire and Cardigan Bay. The University of Swansea and Natural England have also enabled us to agree on using acoustic releases all along the Bristol Channel. Hopefully they'll be going in this spring. And this year we've added a number of oyster, mussel and seaweed farm sites around the coast, which has been a very useful way of getting extra FPODs in the water. Finally, to fill in the gaps and add some offshore data, Celtic Sea Power will be undertaking a baseline measurement of cetacean distribution in the floating offshore wind lease areas in the Celtic Sea using FPODs. So that data will be available to CAT2. So that by the time you put all this together, we do have quite a lot of coverage over the southwest approaches and around the southwest coast of England. Where are we? There we go. With CAT, we are sort of aiming for long-term fixed points monitoring. On that point, in February, in collaboration with Southwest Coastal Monitoring and Fugro Met-Ocean team, we started a trial deployment on the Coastal Observatory wave buoy mooring off Looe. If we can find a safe, serviceable solution for FPODs and wave buoy moorings, we could think about extending our monitoring to some long-term sites that would offer otherwise inaccessible places to CAT. That's quite an exciting thing to look forward to. Wherever possible, we link these acoustic monitoring surveys with the visual surveys from land and sea that we've heard a lot about earlier this evening. Where I am in Falmouth, the Exeter Student Union Marine Society and Falmouth Marine Conservation have had some spectacular sightings just off Pendennis Head here recently. So we work with people in both of those groups to try and link their visual data with our acoustic data coming back from the FPODs. When the data comes back, it looks a bit like this. These are porpoise feeding buzzes. The top line there is the click rate. You can see it increasing up to around 600 or 700 clicks per second. We can tell quite a lot of information from these. Their echolocation clicks. So given the speed of sound in water, we can tell roughly how far ahead the animal is looking as it's clicking, and feeding buzzes as they close in on the prey ramp up quite quickly. Along the bottom line there, you can see a nice wavy edge along the top, showing the sound level, level of the clicks as they come through, and that nice wavy line is the beam sweeping past the FPOD, and that's happening in time with the tail beats, so we can get some information about how the animal is moving too. It's a fascinating amount of information in there once you start delving into it. For the CAT project, we use a lot of citizen scientists. So we have freeware from Chelonia that people can use to analyze this data. And we have a few quick, easy button pushes that we can get information like these graphs out just within a few minutes of recovering the SD card from the FPOD. Makes it quite simple to compare activity patterns such as the dial graphs along the top there with volunteer groups in other areas. What we're seeing there in the dial charts along the top is fairly typical of what we're seeing all around the southwest, and that's there is a lot more acoustic activity in the hours of darkness than in the day. That is certainly a lot more noticeable with dolphins than porpoises, but it's something we're seeing everywhere we go. which is interesting when we link it with the visual surveys. Obviously, the visual surveys aren't happening so much at night, but we are following the tracks and seeing where these animals are going at night when they've finished their hunting out in the seas during the day. We track detection positive hours, 24 hours a day for months at a time. So I think this is an FPOD that Chris Lowe kept off Nuki, off Town Head, I believe. And that runs from the middle of June right through to the 1st of October there. And we can see that the dolphins are in orange and the porpoises are in purple. We're getting up to 18 positive hours a day of detections. The animals are there pretty much all the time in certain places, and it is interesting to see how those distributions move. We're not very good at abundance or even species, but we are interested in how the distribution varies as the animals move around. This is some data from the Fell River, and it's been quite interesting. I've had an FPOD up near the King Harry Ferry on an oyster farm up there. So this is the 4th year now. And the dolphins were coming up the Fell River at night time in the winter occasionally. Just in the past few months, they started occurring around the summer. They started coming in and investigating the area, and then they came back more and more frequently. And this shows the sort of latter half of 2023, where they were coming in on a more or less a weekly basis and staying for a while, always at night. They were coming up the river. Then as we got into December and January, these are the months of December and January, they were coming up the Fell River there by the King Harry Ferry just about every night. They very rarely missed it. And they were staying there for several hours at a time, which they'd never done in previous years. That was quite interesting. We're now trying to repeat this. A couple of weeks ago, we put an FPOD up the Foy River on the lifeboat pontoon up there to see if there is a similar distribution of animals up the river there. We're looking for a site along the Tamar or Plym. That might be a bit more complicated, but we'd like to look into that too. And on Tuesday next week, I'm off to the Isles of Scilly, and we're going to put one in the Isles of Scilly Lagoon, maybe just off Tresco. We get similar patterns there. We ran an FPOD for 6 months off the north coast of St Martin's, and there were detections of dolphin and porpoise just about every day. But colloquially, talking to the boatmen there, they rarely see the dolphins in the shallow lagoon in the middle. So we're wondering if maybe these animals are coming in there during the night time, but that's been an interesting study. This is showing some porpoise social activity, and this is a relatively new area for us that we're starting to look into. I think Nick Tregenza first noticed this behavior in river dolphins in the Amazon. And since then, he's been looking for it, and we're finding it everywhere now. It is a new area, and it is of great interest. So I think that's something we'll definitely be looking for in all the cat data we're gathering. It is this sort of social interaction. The next step for me really is to take all the raw data that we've gathered over the past couple of years and start uploading it to an open repository. So we're going to put it up on Figshare. It should be available to everybody there, and the free way to analyze it from Chelonia is on our website and available to everybody too. So we are hoping to get some groups together to look into different areas of cetacean research there. Thank you. That was hopefully the last update I'll do on the CAT project. Next time I talk, I'd like to talk much more about the information that's coming back and come back with some results and studies. But if you are interested in looking at this data or helping us gather this data, then please do contact me. You don't need to be a biologist. We keep it very simple. But if you are a biologist, we hope there will be something of interest in there for you. And thank you very much.
Brilliant, thank you, Joe. So next up, we've got Simon Ingram from the University of Plymouth. So I'll pass over to you now, Simon.
Lauren. and thanks for organising such a great cetacean focused event. It's brilliant to see so many people online today. So I'm going to give you an update on the work that we've been involved in with bottlenose dolphins on the Channel Coast with the South Coast Bottlenose Dolphin Consortium. So first of all, I just want to sort of acknowledge the wide participation in this project. So this is a really big effort from lots of people that have provided data and time as part of the South Coast Bottlenose Dolphin Consortium, including Duncan, who's provided masses of data. And specifically, I want to mention MSc students who've helped analyze and pull together such a wide data set, particularly Freya. So Freya Diamond, a lot of what I'm presenting today is Freya's work that she did as an MSc student at the University of Plymouth, as well as Becky, Shauna, Saskia, and Jess, who've all done MScs on this data set. Freya would have been presenting this talk herself, but she not had an operation recently. So I just want to sort of give a little bit of a background about coastal bottlenose dolphins and why they're so special. There's been a building sort of series of findings over the last decade or so that have been showing that coastal bottlenose dolphins that live very close to our shores and inhabit estuaries around Europe and other parts of the world are different from the animals that we see in pelagic waters offshore. And this has been shown through genetic analysis. This is a figure from a paper by Malaya and Buchanan showing differences between pelagic bottlenose dolphins that you can see in the bottom left panel there and the coastal animals that are shown in the other panels, and differences between coastal bottlenose dolphin populations around the shores of Western Europe, which is really interesting. Previously to this sort of findings, these dolphins used to be treated as one very large stock, and now we're starting to see a building series of findings that are building evidence to show that these are isolated animals that are genetically different from the pelagic animals. This is also shown in skin stable isotope analysis that shows that coastal animals separate out quite clearly from pelagic animals using nitrogen and sulfur isotopes. This is a paper by Marie-Louise, who did her PhD on the bottlenose dolphins down in the Gulf of Normandy. So if we look at the sort of timeline of these animals around the coast, this is a mitochondrial sort of genetic clock that we can look at mutation rates over time, and the x-axis there is millions of years. So the present is on the right side of that axis, and you can see the different groups of coastal and pelagic animals on the listed on the right-hand side. So we've got pelagic Eastern Atlantic at the top, coastal South, coastal North, and then at the bottom we've got the Eastern Med and the Black Sea populations. And you can see the division where those groups split is showing us the time in which they diverge from each other. Now, what's of interest there is the pelagic Eastern Atlantic at the top and the split from the coastal South and coastal North. And that happened about 15,000 years ago. And more recently, about 7,000 years ago, the coastal South diverged from the coastal North. So if we look at a map, this is a habitat model showing the change in habitat suitability over time, looking at the sort of period of time when the coastal and the pelagic animals diverged using that genetic clock. And we can see that about 15,000 years ago, at the last glacial maximum, the water conditions were too cold for bottlenose dolphins around our coast, and ice covered some of the parts of the coastline. And as the water started to warm, those animals started to move into new habitat. And the animals started to found populations around the shores of West Europe. And in fact, we know that the animals that are there now are direct descendants of the founders that moved into the coastal habitat when this habitat became available to them 15,000 years ago, which is really interesting, which makes us realize just how vulnerable these animals are. They're living in highly impacted coastal areas. They're also being used as part of a wide monitoring network, as part of the MSFD as indicators of good environmental status in the Marine Framework Strategy Directive around Europe. So you'll notice there the light blue line around the coast of Devon, Dorset and Cornwall is the population that we have locally, and these are part of that coastal north group of this coastal ecotype of bottlenose dolphins. So the animals that are in that sort of group, that population, they've been studied intermittently since the early 90s. So Colin Wood did a study in the mid-90s from a kayak, taking pictures. He built up a catalogue and catalogued about 51 individuals. Now, data collection has been very patchy over the last few decades, but a paper by Stephen Pikesley and colleagues at the University of Exeter showed bottlenose dolphins might be very frequently sighted around our coast, but there's been a decline since the 1990s when Colin Wood was doing his study. So this led us to be concerned about the conservation of this population. We didn't really have very much evidence. I spoke to JNCC, they said, go away and find some evidence. And that's when we formed the South Coast Bottlenose Dolphin Consortium. It started off as a Southwest initiative, really driven by Cornwall Wildlife Trust, because we were sort of focused mostly on the Southwest Cornish coast. And we formed a group and collated data that already were being collected by different organizations to try and make the most out of all of those data by analyzing them together. So this came from members of the public, ferries, marine tour operators, one of the key data providers, as I mentioned, land-based observations, so organizations like Sea-Watch and other charities that were able to provide us with data. So we put all those data together into a database. We tried to raise awareness to try and increase the sighting report rate, which is an ongoing part of the project. And then we collated all the data that were available. We separated out the coastal animals from the pelagic animals using social indices. And then we estimated abundance using this Bayesian multi-site method that Shauna published in late 2023 in Animal Conservation. So we estimated that there are fewer than 50 animals in this population, which is pretty low for coastal bottlenose dolphin populations. So then we started thinking, well, the animals are distributed. If you look at this, if you look at this map, you can see sightings are distributed not only around Cornwall, but all the way up the Channel coast as far as Sussex. So we started to sort of spread our effort and bring more people involved into the project and to try and analyze the data across the whole of that coastal area. It's very difficult to designate as a special area of conservation or another MPA when you've got very mobile animals that are distributed so widely. So we started thinking about threats. And this is why we've got this this weird cartoon of a camel. So you think about these animals, they're living in very highly impacted coastal environments. They are, you can think of them as swimming around with a large burden of cumulative impacts that are stacked up on top of them. Initially, that would have been direct takes from hunting, and we know from studies that there are extinct coastal populations of bottlenose dolphins that used to live in the Humber from bones that have been recovered from Viking middens, showing an extinct population used to live in the Humber. We've been fishing heavily in the coastal waters of the UK for centuries, so we've been depleting their potential prey. This risks regime shift in the trophic structure of our ecosystems. Then we've started to invent and develop and deploy diesel engines in ships, so we get disturbance and noise that Beth spoke about earlier. We've started to focus on visiting these animals in their natural habitat, which is great, but that increases disturbance levels. More people have got leisure boats, people go out, especially with things like jet skis. There is a big potential for disturbance and collision from recreational boating. These animals are also bioaccumulating heavy metals, PCBs and other endocrine disrupting organic pollutants, which persist in their fat tissue throughout their lives. We don't really understand how climate change is going to impact them, but it probably will. And we've got a risk of declining reproductive success and survival due to some of these endocrine disrupting chemicals, and a reduction in prey and population fitness being affected. And then ultimately, we end up with the potential of fragmented communities and a loss of population resilience, which is sort of what we're worried about with this small population along the Channel coast. So once we get low population size and they're isolated, they're at great risk, especially in an area of coastline like the Channel, which is very highly impacted by human activities. So just to give you one example, this is a figure adapted from a paper by Paul Jepson that was published in 2016 that really sort of shocked everybody at the level of PCBs in the blubber tissue of stranded harbour porpoise, bottlenose dolphins and killer whales around the coast. And the red line there was the previous highest levels that had been published for these species in the literature. And the black line is the level at which we know they have there is a physiological effect of these chemicals. So they really are sort of burdened with quite high levels of some of these pollutants. So one of the things that Shauna did was try to model exposure to human impacts, looking at fisheries, looking at fishing, and looking at pollution around our coast. And we haven't really solved the problem, because wherever they go along the Channel coast, they are being exposed to a whole range of different human impacts. So that sort of brings me on to the sort of recent sighting data. And you can see here, this is the sighting data from 2007, the beginning of the data set, up until last summer. And you can see that there was a peak in sightings 2017, 2018, around that period. And then after the pandemic, we've seen very few sightings. Obviously, that's unrelated to COVID, but we've really not seen them pick up since people have been out on the water again since the pandemic. So we are really worried about what's going on with these animals. We're going to really try and campaign to reinvigorate sighting reports for this summer. If we look at the location of these sightings over the last few years, you can see that back in 2015, 16, 17, 18, we had lots of sightings around North and West Cornwall, with sightings around Portland, in Dorset. But as we wind the clock forward to 2020, 21, 23, there are very few sightings. In fact, you can only see a very small hot patch around Brighton in the bottom right panel there. And that's really the only sightings we had from last year. So we're getting increasingly worried about the status of this population. So one of the things that Freya did is she looked at the age cohort structure of the sightings that were being reported to us, because we were worried that we weren't seeing lots of juveniles that you would normally expect to see when you encounter groups of bottlenose dolphins. And in fact, of the sighting reports, about 90% of them consisted of schools with just adults, so no juveniles or calves present in those 90% of all sightings. Now, we have to have a caveat. These are unstandardized data. People are probably drawn towards the big adults that are easier to photograph and see, but still this is a bit worrying. So Freya then compared the data that we'd got from our citizen science data with published studies around the world, so all the way to New Zealand, Australia and Florida and other parts of Europe, to try and see whether or not the population cohort age structure matched those studies. And as you can see in this table, the photo ID catalogue, so this is individuals that have been added to our photo ID catalogue. So over 96% of them are adult, and only 1.8% are juvenile subadults, and very few calves, which is remarkably low if you look at other populations. And I did my PhD in the Shannon, which is the bottom line on that figure. And we can see that the breakdown is 55% adults, 17% juveniles, 28% calves. So this is a remarkably different age structure in the sightings that we've got. And if we look at birth rates, birth intervals, and compare again between our data and those other studies, we can see that our birth rate is extremely low, and lower than any of the other published data from the literature. So again, low birth rates, very low numbers of juveniles and calves in the encounter data that we're getting. And what we're really worried about is that there is a risk that if this population is in decline, the first thing you'll see is a hollowing out of the age structure with a lack of recruitment of young animals into a reproductive population. And there's a risk of the alley effect kicking in, where basically population decline turns into a downward slide. And the last thing we want is this population to slide into local extinction. So one piece of good news to end on is that partly because of the work that we've been doing in the consortium and other data like Orca's data, collecting ferry sightings data and other ecotourism data that's being collected around the coast, we have managed to get an important marine mammal area identified for the Western Channel, which covers the range of bottlenose dolphin sightings in the Western Channel and other parts of the Channel coast on the French side of the Channel. So hopefully this is going to be a sort of step forward in terms of literally putting them on the map for hopefully better future protection. So in summary, we've got multiple lines of evidence that are identifying the coastal ecotype of bottlenose dolphins that are ecologically and socially separate from the pelagic animals. These animals live in coastal populations. They live very close to the shore. They're direct descendants of the founders from 15,000 years ago that settled along our coasts. They're living in very highly impacted marine environments along the shore, especially in the Channel coast. And worryingly, we appear to have a population on the shores of the English Channel that appears to be in decline. Thank you.
Thank you, Simon. That was great. And we'll move on now to Anthea from Cornwall Wildlife Trust, who's going to be talking about marine strandings data. So I'll pass over to you, Anthea.
Right, so I'm Anthea and I'm the Marine Strandings Data Officer at Cornwall Wildlife Trust. And tonight I'm going to talk to you about the strandings reported to the Marine Strandings Network over 2023 with a focus on cetaceans. I apologise in advance to those of you that were at the Marine Strandings Forum just over a week ago, because nothing much has changed since then, so bear with me. Hopefully you'll enjoy it a second time. So here's an overview of all of the strandings reported to us at MSN since 2003. We record all marine animals that strand and reported to us, and we fully record with measurements all cetaceans, seals, turtles, and large sharks. You can see here that since 2016, there's been a huge uptake in strandings. Some of the higher numbers are from specific events like the storm events with the birds and PIB and avian flu last year. But as I go into concentrate a bit more on cetaceans, you will be able to see that, like Duncan and the others have been saying, these sightings of live animals is being reflected in the number of strandings since 2016. So looking at the strandings and comparing them to 2022, you can see them of note how many more cetaceans stranded in 2023, 242 in total, whereas it's only 157. And you can see the majority of that comes from common dolphin strandings, which are over double they were in 2022. Which again is reflecting this uptake in seeing many, many more. Right, yes, so as I was saying, you can see that the common dolphins are much, much more, and whereas harbour porpoise strandings has stayed pretty much steady with similar numbers. So looking a little bit more in cetacean strandings by species, you can see again in 2016, there's been this complete uptick in numbers of strandings. A small dip last year in 2022, and then a rise again last year. And this is being reflected in the live sightings. So I'll just go into a bit more detail and look at cetacean strandings by month. You can see that the general trend is normally very busy winters with the storms and things getting washed in more often, and a quiet summer. Whereas, as was also seen in some of the other presentations, there was a big spike in August last year. And these were quite fresh animals because a lot of those were able to go for post-mortem with CSIT. So harbour porpoise and common dolphins continue to be our most frequent cetacean strandings. I'll just go into a bit more detail about that. So as has been talked about already, you can see from our stranding figures that there's been this decline in harbour porpoise strandings, and it's been steady over the last few years, but at a much lower level than back in the early noughties. And the common dolphins since 2016, the number of strandings of them is very, very high. And last year was the highest we've ever recorded. And already this year, it's looking like it's going to be another big year, busy year for common dolphin strandings. So I'll just look a little bit about cetacean bycatch. So the accidental catching in live fishing gear, and we identify this through post-mortem and beep analysis, which is the use of in situ photos, where we look for particular features that are linked to bycatch. So you can see last year, along with the increased number of dolphins, we also had an increased number of incidences of bycatch, both identified through post-mortem and beep assessment. So I'll just go through a couple of examples of the bycatch that we had last year. So this was a little dolphin that is actually in the initial, my very first slide. It was initially seen out at sea, and then fortunately it stranded up Penpole Creek and was able to be retrieved for post-mortem. You can see on this photo of the pectoral fin, the linear encircling marks that cause notches. That's from the netting, and that's what we would be looking at. But fortunately, going to post-mortem, James was also able to confirm that with more internal features. This dolphin was found at Porthbean Beach, and you can see here on this one the very classic tail amputation with very clean linear wounds to the tail stop. This happens when the fishers cut the animals out of their nets. And it's very common to see this in bycatch animals along the southern coast, a lot around the Rain Peninsula and the St. Austell Bay area. And then finally, this dolphin that was found on Downderry in December. It was pretty obvious that this was some bycaught animal because it's still in the bit of net, and you can see that the net has cut straight through into the fluke, and you can see the very clean linear features that we are looking for when we're doing our beep assessment. So just to talk a little bit about a few notable cases. So we had this juvenile female fin whale who stranded in an incredibly prominent position on Fistral Beach in Newquay back in the winter. She attracted an incredible amount of attention, as you can imagine, being in such a popular place. But what made it so notable was that we had the most amazing response from our volunteers, from Coast Guards, from the police. There was an amazing effort that went to help organise the Cornwall Marine Pathology team come and do an in situ post-mortem on the beach. And we had lots of volunteers around talking to the public because they were incredibly interested about it. And it was an amazing learning experience for so many people to get involved with the amazing life of this animal. And another amazing bit of effort-based teamwork was this young pilot whale that stranded at Marazion, and it required an epic team effort to get it up the steps and retrieved for post-mortem examination. And James says it's the largest thing he's done in his new PM room. So hopefully we won't get anything bigger than that up there this year. There were 4 recorded cases of bottlenose dolphin attack with us last year. 3 harbour porpoise, who were the usual victims of bottlenose dolphin attack, and just the 1 common dolphin, which is rarer to see. You can see here the deep, ragged, regular spaced marks that rake marks that the bottlenose dolphins leave, which makes it very clear that it's a bottlenose dolphin attack for us. So I've whistled through that really quickly because I'm aware that we are very low on time at the moment, and just want to say thank you to all our amazing partners and all the volunteers that put themselves out there in the howling wind and rain when we get all our call outs. And yeah, 2024 is looking to be just as busy. Thank you.
Thank you, Anthea. That was great. So we're on to our final speaker now, and we're going to go back to Dan Jarvis, who's going to be talking about cetacean live strandings this time.
Okay, so just while Lauren's sorting that out, just to reintroduce myself, earlier on I was Dan Jarvis, a Sequest volunteer for Cornwall Wildlife Trust. I'm now Dan Jarvis, Director of Welfare and Conservation from British Divers Marine Life Rescue, just to make that definitively clear who I'm representing for each of my talks this evening. The talk that I'm presenting now sort of follows neatly on from Anthea talking about the deceased cetacean strandings. I'm going to now cover the majority of the live strandings that we had during 2023. There were quite a few of them, the large majority in Cornwall, so we won't have time to go into a lot of them in great detail. But I'm just highlighting some of the key ones here. So take it away, Lauren. Feel free to move me along. The first stranding that we had in 2023 was actually a fin whale. This live stranded in early January near sort of on the eastern side of Mounts Bay. It was a particularly unpleasant evening. It was very rough, seas and strong winds. There was nothing that we could do for the animal. It was completely inaccessible, being washed up on the rocks. But in fact, when BDMLR medics first arrived there, the animal was determined to already have been deceased, although we had video of it previous to this showing it to be alive. You can click on the next photo. There's a second photo to come up. Thanks, Lauren. So this animal, therefore, we then handed over to the Cornwall Wildlife Trust Marine Strandings Network. While it was washing around there, it did roll over. We were able to determine it was a female. We could also see that it was in poor nutritional condition, but much to our surprise, it completely disappeared by the morning and it was never relocated again. So a post-mortem examination wasn't able to be carried out on this animal. Next slide, please, Lauren. This was followed shortly afterwards by a common dolphin live stranding on Hale Beach. This also died before BDMLR responders were able to get there. And it was an animal that was in really poor condition. There's a couple more slides to show that, Lauren, if you want to click ahead a few seconds apart. This animal was obviously not going to be a candidate to be refloated. It was in a very poor nutritional state, which I mean by that as in it's had a long-term health decline. It's not been feeding for a long period of time, and simply putting it back in the water isn't going to solve that problem. It will continue to decline in its health, and probably the whole reason it has stranded is because it's no longer coping with being in the sea. So there wasn't really anything, of course, that could have been done for the animal had it survived longer. Next slide, please, Lauren. We then had a little bit of a gap, and then we came into June. A common dolphin that live stranded in sort of a large rock pool inlet at Boobies Bay. Again, it wasn't the nicest weather on that evening, and the animal may have been there for some time before it was seen. We're not quite sure how long it was in there for, but it was in this small rocky sort of pool for some time, and when our BDMLR volunteers got there and began observing it and getting ready to go in the water with PPE on, it actually managed to get itself wedged under a crevice and was submerged for a period of time, upon which it was able to be retrieved, but it actually went into convulsions and died a few moments later, unfortunately. So this animal obviously wasn't doing very well either, unfortunately. Next slide, please. In July, we had a spate of striped dolphins, which was quite unusual. The first one there stranded at Sandymouth. The next day, another one stranded at Widmouth Bay, so both up in the Bude area of North Cornwall. So presumably these two animals were related in some way to one another, i.e. being from the same pod. And then a week or two later, we had an incident down at Penberth Cove where we were alerted to a pair of dolphins circling close inshore for the afternoon. By a surprising degree of luck, we actually had someone who was snorkeling report it to us, and they'd been out and photographed them underwater, which is the top photo you can see on the right there. And this enabled us to confirm it was actually striped dolphins rather than common dolphins, which we might have assumed they were without any other evidence to go on. Those two animals actually didn't strand, they moved off and were not seen again. However, a few days later, just across over at Porthleven, so not too far away, we did have an animal that stranded in very poor weather conditions in front of the clock tower on the rocks behind the pier. This is the only photo that we had of this animal on the right-hand side at the bottom, but it's just enough for us to be able to say that it is a striped dolphin again, and potentially is an animal that was in that pair over at Penberth Cove not long before. So that animal was actually washed out by the tide just as our volunteers got there. We don't know what condition it was in, unfortunately. Then we have quite a difficult incident, this one in St Ives during August, which illustrated by the two photos at the bottom. You can see had an enormous crowd of people all around the harbour watching everything that was going on. This was a common dolphin calf that was first seen early in the morning nearby at Porthminster Beach and was then tracked as it moved its way into St Ives Harbour over high tide. It did appear to be accompanied by presumably its mother, a larger common dolphin, but she, or presumably she, was quite standoffish. She wasn't staying close to the calf. She was staying on the other side of the harbour, quite a distance away near the entrance. And after the tide turned and it started going out, she actually left completely and wasn't seen again. So the calf was left on its own in the harbour. But from our observations on the harbour side during this time, we could see that the calf was quite stressed. It was not in a very healthy condition, unfortunately. And as the tide went out, our team went into the water and were able to maintain it in the shallows as it became stranded on the sandbar in the mouth of the harbour. And of course, managing the crowd in this case was very, very difficult. The animal was extremely stressed. We'd already come to a decision to euthanize the animal once the vet had arrived, but in fact, it passed away of its own accord before then. So it was really important to try and message that, communicate that very calmly to the crowd, as of course, dealing with people in these incidences. Emotions can run quite high. Sometimes it does mean we get some abuse in these incidents, as people think that all of the animals we go to should live and be put back in the sea. But our role at BDMLR is to make the right welfare choice for the animals. So if it had survived long enough, of course, as I've already mentioned, it was in poor condition already, and simply putting it back in the water wouldn't rectify that problem. It would continue to suffer until it died one way or another. But as it was in this situation, the animal passed away before we could do that anyway. This was actually met very warmly by the crowd, just taking that time to explain the whole situation properly to them and to have people listen. It was a really good example of trying to communicate effectively to quite a large audience, which is really quite scary when you stood there on your own in front of them, trying to tell them this. And a lot of people were really understanding. There were only one or two people who were difficult to deal with. So our team did a fantastic job under really difficult circumstances with this one. Next slide, please, Lauren. We then had, in August, a real blip in strandings. We had quite a lot of incidents throughout August, starting with this one. We don't actually have any photos of the animal. It stranded just before it was getting dark at Lamoran, which is in the top right of that map. So quite a long way up the Fell Estuary, quite a long way up one of the intertidal creeks. It was dark, it was stormy, and it was a long way out on mud flats, which were really dangerous, and there was absolutely no way anyone could safely get to it. We had the Coast Guard out and they agreed, and we all stood down for the night. A few days later, a deceased dolphin, common dolphin, was found in the area, so presumably that was the same animal. We, of course, did search the area the next day, but we couldn't find it at that point, so it must have washed in and out somewhere on the tide and not been found until it was a few days after. Next slide, please. We then had a really difficult incident a couple of weeks later at Myler Bridge, or between Myler and Myler Bridge in the creek there. It's a bit of a well-known stranding hotspot to us, but sometimes we have had animals in here that have managed to find their own way out and we've not had to intervene. So we had a group of 8 common dolphins that were seen swimming in here, but unfortunately as the tide went out, they quite quickly got stuck on the mud flats here. So our team attended along with the Coast Guard and also some local residents who have been calling them in and helping us monitoring them through the morning. We're able to go out on the mud flats with all the PPE gear on, of course, again, but also with the help of paddleboards and kayaks to get across the mud. It was a really difficult incident. 7 of the animals were successfully refloated in this one. They were taken downstream on the paddleboards and released back into Carrick Roads, but unfortunately one calf passed away during this incident, I'm afraid. Next slide, please. I thought that might happen. Yeah, I've got 2 very weird files that won't go the right way up for some reason when you save the presentation, so please excuse this slide. But if you turn your head 90 degrees, hopefully you can make out another muddy dolphin rescue. This is up at Anthony on the Tamar River, just on the Cornwall side. This was a common dolphin calf, maternally separated from its mother. There was absolutely no sign of her. And it was also in poor nutritional condition, indicating it probably had been separated for quite a considerable period of time and wouldn't have survived on its own. This animal, we had to use a couple of paddle boards again to slide across the mud to recover back to the shore. Luckily, it wasn't too far out, so it was a relatively easy operation to do that very safely. And our vet attended, and this animal was put to sleep as a result of its condition. We had this really sad incident then towards the end of August. This is a Risso's dolphin calf. It's quite rare for us to get Risso's dolphins live stranding, but this is our first calf that we've actually dealt with down here in the southwest. This came up at Harlem Bay. It actually died before anyone could get there anyway, but it was in terrible condition. But you can see it's extremely young. It's still got visible fetal folds around its body. But what was also really interesting was that it had a lot of rake marks from common dolphins, which when you think of rake marks being on cetaceans, you think of bottlenose dolphins attacking porpoises and so on. But these were not bottlenose dolphin rake marks. They were actually caused by common dolphins. So there's been quite an interesting interaction between common dolphins, potentially a group of common dolphins, and this maternally separated calf. So we don't fully understand what that means or why, but it's a very interesting case to note all the same. Thank you, Lauren. Oh, there's one more photo of the same animal there. Carry on. Moving on into Devon, we had this stranding of a common dolphin at Northam Burrows, and this animal again, unfortunately, was in quite a poor nutritional condition. We did it for whatever reason last year. We had a lot of animals in really poor condition coming up, so there wasn't a lot we could do with them when we got there if they weren't already deceased. So this sadly again was another animal that had to be euthanized on welfare grounds, as it clearly wasn't going to survive much longer in this condition. So our team did a really great job dealing with that one again. Moving back to the south coast, similar to the stranding at Anthony that we went past a moment ago, we had another dolphin alone up in the Tamar River on the Cornwall side again at Melbrook in September. This animal was once again an animal in very poor nutritional condition, clearly not doing well for itself for whatever reason. So this animal was recovered back to the shore with the assistance of the Coast Guard team there and euthanized once again. Thank you, Lauren. This was another quite difficult incident involving a fin whale, this time east of Linton on the north coast of Devon during October. As you can see from the photo, hopefully, this fin whale stranded at the bottom of a huge cliff. There's absolutely no way to get down to it, and it was also very rough. Like the fin whale back at the beginning of the year at Perraneuthno, this animal was actually dead by the time, or around the time, our volunteers arrived and observed it from the cliff top. But again, due to the difficulty of the location, it wasn't possible to carry out a post-mortem examination on this one. There's another photo in there, I think, Lauren. Thank you. Next slide. And then we come towards the end now. We finished up the year, again, in really quite stormy conditions. A common dolphin was seen entering Hale Harbour very early in the morning by someone checking on their boat, as a number of vessels were damaged overnight during the storm. And this animal found its way into the RSPB reserve at Lelant Saltings, where it was observed swimming with difficulty during the morning for a couple of hours before it became stranded a long way out on the mud. Unfortunately, this meant it was inaccessible for us to get there. We had the Coast Guard once again supervising safety with us, but it was agreed that it wasn't possible to get to. But either way, the animal actually passed away quite quickly, so there would have been very little we could have done had we been able to get to it. The animal was noted to be, again, in poor nutritional condition, but it could not be recovered from its location to be taken for a post-mortem examination. So I think that brings us to the end now, Lauren. A huge thank you to everybody that we work with, particularly organisations like the Coast Guard, Cornwall Wildlife Trust Marine Strandings Network and Cornwall Marine Pathology Team, and everybody else in the background in one form or another who we work with to deal with these strandings, and of course to our BDMLR volunteers on the ground dealing with these incidents as well. And thank you, Lauren, for sharing my presentation and keeping up with both of them tonight for me. And that brings me to an end now. Thank you.
Brilliant, thank you, Dan. So that is all of our speakers this evening. We have overrun a little bit, but we do have time for some questions. So you should, I think, be able to put a little virtual hand up if you have a question, or you can write it in the chat and I can read it out to the speakers. I know that they've been doing a really great job of answering questions as we've been going on. So feel free to just take a few minutes, add any other questions into the chat. Please do also mention who the question's for so that we can direct them to the right person. So Kirsten has just said that she'd love to know more about the loo-based acoustic device, please.
Hello, yes, there is an F-pod recently been deployed on the Wave Buoy, and the coastal monitoring have 37 sites all around the English coastline. That one is run by the Southwest Coastal Monitoring Team, which is Izzy Kelly was our contact there. Amelia Bridges runs the local Loo Marine Conservation Group. Between them, they all got together and agreed that we could put an F-pod on there. I took it up to Fugro at Porchester, who service all these sites, and left it with them. And it went out on the 1st of February. So it's currently out there recording at the moment. It'll stay out there for about four to 6 months. When Fugro bring it back in, we'll have to assess how successful that deployment was, and based on that, look at whether we could possibly use other wave buoy sites for acoustic monitoring too. It is a big hope for the future that we can get on more sites. Okay.
Thank you, Joe. Any other questions in the chat? Okay, that's fine. We can leave that there because I can see that we've asked quite a lot of questions throughout the sessions, which is really great. So I'll just say another thank you to all of our really brilliant speakers. Thank you to everybody for joining us. As we said, apologies for the miscommunication with the start time. Everything has been recorded and it will be on the Southwest Marine Ecosystems YouTube channel, so you can go back and catch up on that first talk. So thank you everybody for joining us, and hopefully see you at events soon.